things that we're going to do today is learn how to graph absolute value functions. So if you had y equals negative x plus 4, and I'm going to put a blue box around this equation. If you wanted to graph that, would you agree that its y-intercept would be 4? And its slope is negative 1, so it goes down 1, over 1, down 1, over 1, down 1, over 1. And if I drew that, and I'm going to draw it right beside this, here I have the graph of negative x plus 4. And if we plugged in the values, and if I could click on this, it's not letting me. If we plugged in the values, well, when I put absolute values, this would stay 4, this would stay 2, this would stay 0, but this would become 2, and this would become 4. And so what happens is that these points that were negative all get reflected up over the x-axis. And it makes your absolute value graph sort of two straight lines put together. Makes it look like a V. So we call this the absolute value function, where you put in something that you knew before how to graph. We knew how to graph the blue one. And then all the negative y values have to become positive, and that's like flipping it over the x-axis. Another word that comes up more and more, especially in calculus, is critical point. The x-intercept here is a critical point because that's where our absolute value changes direction. And really an absolute value graph is two lines glued together. One line and then another line stuck together at that critical point. So we go to example 1 here. We want to sketch the graph of y equals the absolute value of 3x plus 6. Identify the intercepts, domain, and range. So we're first going to just graph the inside. And that's a graph we know how to do. We know how to draw y equals mx plus b. 1, 2, 3, 4, 5, 6. So we would know that we have an x-intercept at 0, 6. And it has a slope of 3, so I could go up 3 over 1, or down 3, back 1, down 3, back 1. And it's going to be important when graphing absolute value graphs to find the x-intercept as well. So this is our y equals mx plus b line. Then in green, I'm going to graph the absolute value of that. And all that's going to do is, you know that if things are positive, they stay the same. So this part where the y values were positive stay the same, all the way to negative 2. But then this point on the blue graph, which was negative 3, negative 3, on my green graph, I'm going to have negative 3, positive 3. And my absolute value graph will look like a V, changing at that critical point at the x-intercept. So identify my intercepts. Well, for my green graph, my y-intercept is at 0, 6. My x-intercept is at negative 2, 0. The domain is still everything. There's no x value. You're not allowed to put into an absolute value equation. And the range is your y values are now bigger than or equal to 0. You can circle 4, 5A, 6, 7A, and 10A and B.